Hello everyone, let's do some tetrahedral meshing in Rhino3D with the TRmesh tetrahedral mesher. You get it by package manager and installing TRmesh, and then this will give you either a command TRmesh, it will give you an entrance here in the panels menu and under TRmesh. It gives you this menu entry here, and it gives you an entry under this gearbox icon. Okay, so there are many ways to bring this panel up. Alright, you start with a solid. Let's start with some simple cylinder. You select it, you stage the selected objects for meshing. The grid-based one is a classical one based on Tetrahedral. You hit OK Mesh Staged Solids. You end up with this one, or you choose the fuzzy mesher, which tries to scan the geometry with a point cloud first. Once you are happy, you can increase the resolution and try it again, and you can enjoy as you watch the mesh quality go up, which happens when you peel off sliver tetrahedra and hit the remesh button. You can repeat these once you know that peeling sliver tetrahedra is not going to damage the topology of your TRmesh. And now we can see that the mesh quality is slowly going up. 0.02 is already a very good value for such a big mesh with 26,000 tetrahedra. Alright, let's try something with a hole. Let's try a torus here. We clear everything, we stage. Let's first try the grid-based one out. It gives a very regular mesh, which can also be remeshed and so on, or you try the fuzzy one. So the idea is that this group of buttons here is for background meshing, and this group of buttons here is for remeshing once the mesh has captured your topology nicely enough. So if there are missing dents that you want your mesh to capture, you just do repeat the background meshing, and you can peel off sliver tetrahedra. First you'll be a little cautious, and then you'll slowly increase the threshold until no tetrahedra, no sliver tetrahedra are left to be removed. And now you can hit the remesh button even successively, all the while increasing the resolution and peeling sliver tetrahedra, and you can see that the mesh quality goes up and goes up and goes up, and you get this very nice finite element mesh. Every tetrahedron looks very regular here. This is an extremely good mesh for finite element analysis. Okay, let's try some real actual meshing task here. We have this part of an I-beam. It looks like this. There's a plastic insulation in the middle and two parts of steel around it. These solids are watertight, nicely modeled solids. You select them for meshing. It looks nicest in the wireframe display mode. I recommend to use the fuzzy remesher, because the fuzzy remesher's new contribution is to deal very well with curvature here. You can compare it with the grid-based mesher. In any case, you stage it. You have 3 new staged objects, which are also drawn in turquoise. You hit OK Mesh Solids. Now on my machine, you first need to make sure that you hit the clear button and you only select adjacent solids, so otherwise it's not going to work. It says meshing in process here. Now the fuzzy remesher scans the geometry with the point cloud, and you can gradually increase the resolution, peel sliver tetrahedra, and then remesh in a kind of iterative process until you have reached sufficient mesh quality. So as you can see, with a little patience, you arrive at very nice, high quality meshes. And once you hit the remesh button, you can successively reach a better mesh quality. But first we need to sufficiently increase the mesh resolution. We wait about 20 seconds on this machine. My computer is very old. There we go. We peeled some sliver tetrahedra. We hit the remesh button. And we enjoy as our mesh quality gets better and better. 0.01 is already a very acceptable value for such a complicated geometry with a lot of curvature. Notice that the curvature here has not caused any problems for the mesher, and every TED looks very regular, and the geometry has been represented very well by this TEDmesh of about 181,000 tetrahedra. Thanks for watching.